Now let us see another example. The mass of a spring mass dashpot system is given an initial velocity of z omega n from equilibrium position, where omega n is the natural frequency of the system. Find the equation of motion for the following three cases. So first case is zeta is equal to 2, that is overdamped system. Second case is zeta is equal to 1, that is critically damped system. And third one is zeta is equal to 0.2. Now for first case, that is case A, it is overdamped system, zeta is equal to 2. So as it is greater than 1, it is overdamped system. Value of zeta is greater than 1, so it is overdamped system. For overdamped system, the roots of the equation, they are S1 and S2. They are given by omega n multiplied by, inside the bracket we are having minus zeta plus or minus. So here it is plus or minus square root of zeta square minus 1. General solution is given by a e raised to s1t plus b e raised to s2t. So this we already have derived. So s1, for calculation of first root s1, we have to use the positive sign, that is used over here, and for the calculation of s2 we have to use this negative sign. So first we'll let us calculate the value of s1. So omega n minus zeta plus square root of zeta square minus 1. So in place of zeta, correct, we have to substitute minus 2, omega n as it is, zeta square, that is 2 square minus 1 in the under root sign. So these are the real and different roots. So first root is minus 0.2679 omega n. Similarly, S2, for S2 we have to use negative sign. So S2 will be equal to omega n. In place of zeta it is 2 minus square root of 2 square minus 1. So it is again minus 3.7332 omega n. So we are now having the values of S1 and S2. So substitute in the general solution. So general solution is x is equal to a e raised to s1t plus b e raised to s2t. So substitute the values of s1 and s2. So value of s1 is minus 0.2679 omega nt plus e raised to minus 3.732 omega nt. Now differentiate with respect to t. So we can say that derivative of x, that is dx by dt. A is a constant, so we have to take derivative of this exponential term. B is also a constant and derivative of this exponential term. So derivative of this term will be equal to e raised to minus 0.2679 omega n, which is the coefficient of t that you have to multiply over here by chain rule. So derivative of e raised to x is e raised to x, but again we have to take the derivative of this particular term, and that is minus 0.2679 multiplied by omega n. So that we have written over here. Similarly over here also, derivative of e raised to minus 3.732 omega nt is this particular term, entire term. Now a multiplied by minus of this term, so this is minus a multiplied by this entire term, plus minus that multiplication is minus b multiplied by these terms. So here we are multiplying this a and b to these terms. So we can say that this is the value of dx by dt, that is nothing but velocity, that is x dot. So boundary conditions are at t is equal to 0, amplitude is 0, and at t is equal to 0, initial velocity z omega n. So we have to use the first boundary condition, that is this boundary condition, in equation 3. So equation 3 is this particular equation, the previous equation which we have written. So x is equal to a e raised to minus this particular term multiplied by t plus b e raised to minus 3.732 omega n into t. So in place of t we are substituting 0, and in place of x also it is 0. So x is equal to 0, that we have substituted in the left hand side, on the left hand side, and t is equal to 0, that we have already substituted. Now this is e raised to minus 0, that is 1. So this is a multiplied by 1 plus b multiplied by 1. So this is nothing but a plus b. So 0 is equal to a plus b or a is equal to minus b. Now using second boundary condition in equation 4. So equation 4 is this particular equation. Just now we have seen that equation. This is the equation 4. So in that equation we have to substitute this boundary condition, that is x dot is equal to z omega n. That value we have to substitute over here, and in place of t we have to substitute 0. So let us substitute those values. In place of a we have substituted minus b also, and in place of x dot it is z omega n, and in place of t it is 0. 0 multiplied by any term, that is 0. So this is e raised to minus 0. Over here also it is e raised to minus 0. Minus minus multiplication is plus, and rest of the terms are as it is. E raised to minus 0 is 1. So we can say that this b multiplied by omega n, that term we have taken common. So minus minus is plus, so it is 0.2679, that is plus value. E raised to minus 0 is 1, so that is not written over here. Minus b omega n we have already taken common, and e raised to minus 0 is 1, so only 3.732 will remain. So this is this term minus 3.732, that is minus 3.464 into b. So we have cancelled out this omega n from both the sides. So b will be equal to z divided by this negative term. So it is minus 0.289 z. So value of a is this, value of b will be minus a. So a will be equal to minus b. So minus of minus 0.289 z, that is 0.289 z. So here we know that value of a, one step is remaining over here, is minus of b. So b already it is negative, so minus of this minus term, that is plus term, so it is 0.289 z. Now we have to substitute these values in equation 3, so that we'll get the equation of motion, that is x. Displacement is given by this particular term. So value of a is this value, then value of b is minus 0.289 z e raised to this particular term. Now case b is that of the critically damped system, where roots are, both the roots are same, that is minus omega n. So it is repeated real roots. So equation general solution is given by a plus bt e raised to minus omega n t. Differentiate with respect to t. So derivative of this particular term will be equal to, so we have to use, let us assume that this is our u and this is our v. So u derivative of v, so if you consider this term as u and this term as v, so u derivative of v plus v derivative of u, so that is the product rule. So u is this term, derivative of e raised to minus omega n t, plus v as it is, derivative of u. So a plus bt as it is, derivative of e raised to minus omega n t is minus omega n e raised to minus omega n t. This term as it is, derivative of a, which is constant, is 0, and b is constant, but t with respect to t it is 1, so it is b. Take this minus sign outside, so minus a plus bt omega n e raised to minus omega n t plus b e raised to minus omega n t. So this is our third equation, and the boundary conditions are at t is equal to 0, that is initially displacement is 0 and initial velocity is z omega n. So substitute this boundary condition 1, this boundary condition, in equation 2. So x is 0 and t is also 0. So we can say that this is b into 0, that is 0, and this is e raised to minus 0, that is 1. So value of a is 0. Now put boundary condition 2 in equation 3. So x dot, on the left hand side of the equation 3 we are having x dot, so x dot is z omega n, and in place of t it is 0, that we have substituted. So a is 0, this term is also 0, so this first term, total term is 0, so this is minus 0 plus e raised to minus 0, that is 1. So it is b into 1, that is b. So value of b comes out to be z omega n. And now these values we'll have to substitute in equation 2, so that we'll get the equation of x. So x will be equal to a plus bt e raised to minus omega n t. So value of a is 0, that we have already seen. Value of b is z omega n. So x is equal to, so you can write down capital X on this side. So x will be equal to z omega n t e raised to minus omega n t. So this is the equation of motion for critically damped system. Similarly, for undamped system, value of x is m e raised to minus omega n zeta t sine omega dt plus psi, where damped circular frequency is omega n square root of 1 minus zeta square. Substitute the value of zeta, that is 0.2. So we can say that omega t is, if you make this calculation and take square root, it is 0.9797 omega n. Now substitute its value in equation of x. So in place of omega t, we have to substitute this value. So boundary conditions are same. That is, initially displacement is 0 and initial velocity x dot is z omega n. Now important part is we have to differentiate with respect to t. So if you differentiate this equation with respect to t, m is constant as we know. We have to find out derivative of this entire term. So here also we'll use the product rule. This is u and this is v, suppose. So we can say that u derivative of v plus v derivative of u. So first we'll calculate derivative of this particular term. Derivative of sine is cos, and then multiplied by coefficient of t, that is 0.979 omega n by chain rule, plus this sine term as it is. Derivative of e raised to minus omega n zeta t is e raised to minus omega n zeta t, and again multiply by coefficient of t, that is minus omega n zeta. So this is the value of dx by dt, that is nothing but x dot. Now at t is equal to 0, x is equal to 0. This we have to substitute in equation 1. So in place of x, we are substituting 0. In place of t also, we are substituting 0 in our equation 1. That is this equation, the previous equation which we have derived. So in place of x, it is 0. In place of t, it is 0. So it is e raised to minus this terms multiplied by 0, that is 0. Here also this is 0. So substitute these values. So sine 0 plus sine. So e raised to minus 0 is 1. This is sine 0 plus sine, that is sine psi. Now m cannot be equal to 0 because it is a constant term. So sine psi has to be equal to 0. So we can say that psi will be equal to sine inverse of 0, that is nothing but 0. So phase angle is 0. Now using the second boundary condition, so x dot is z omega n, and then in place of t we have substituted 0. Here also in place of t we have substituted 0. So x dot is z omega n. Here it is 0, e raised to minus 0. This is cos omega n into t. T is 0, so this entire term will be 0. Here it is t is 0, so this entire term is 0. Psi is also 0, so this is sine 0, and e raised to minus 0 because t is 0. So this is the equation. E raised to 0 is 1, e raised to minus 0 is 1. This term as it is. Cos 0 is 1, but sine 0 is 0. So this entire term is 0. So 0 multiplied by this omega and zeta e raised to minus 0. So because this sine 0 term, this entire term is nothing but, it is a term which is nothing but 0 term. So this term is sine 0 and sine 0 is 0. So this is 0 multiplied by these terms. So it is 0. Cos 0 is 1. So this is 1. And 1 multiplied by this term. This is also 1. So we can say that value of M is Z omega N. Omega N also we can cancel from both the sides. So Z divided by 0.979. That is 1.021 Z. So this is the value of M, not Z. So value of M is equal to Z as it is 1 upon 0.979, that is 1.021. So these are the values of M and psi which we have already obtained. So that we can substitute in equation 1. So in place of M it is 1.021 Z, and in place of psi it is 0. So this is the equation of motion in the undamped system. So in this way we can derive the general solution for overdamped system, for critically damped system, and for undamped system. Let us see another example on torsional vibration. So here we are having a disk of torsional pendulum which is having a mass moment of inertia of 0.06 kg meter square. The brass shaft attached to it is of 100 mm diameter and 400 mm long when the pendulum is vibrating. The observed amplitude on the same side of the rest position for successive cycles are 9 degree, 6 degree and 4 degree. We have to find out the value of logarithmic decrement, damping torque per unit velocity or damping coefficient, periodic time of vibration. Assume modulus of rigidity as 4.4 into 10 raised to 10 Newton per meter square. So capital G is 4.4 into 10 raised to 10. Mass moment of inertia is 0.06 kg meter square. Then the shaft diameter is 100 mm. Convert mm into meter. So we have multiplied by 10 raised to minus 3. Length of the shaft is 400 mm, that is 400 into 10 raised to minus 3. Now these are the angular displacement 9 degree, then it is reduced to 6 degree, then 4 degree. So if you take the ratio 9 by 6 divided by 6 by 4, that ratio comes out to be 3 by 2. So ratio of consecutive amplitude is same. So 9 by 6 is 3 by 2, 6 by 4 is also 3 by 2. So we can easily find out the value of logarithmic decrement, that is delta. So it is ln of x1 upon x2. So ln of 9 by 6 or 6 by 4 or 3 by 2. That value will be 0.4054. Zeta is also given by delta divided by square root of 4 pi square plus delta square. So substitute the value of delta, so that we will get the value of zeta, that is 0.0644. Polar moment of inertia for the shaft is pi by 32 d raised to 4. So that value will be 9.817 into 10 raised to minus 6 meter raised to 4. Now according to the torsion equation, T upon J is equal to G theta over L, or T upon IP is equal to G upon Gj upon L. So according to torsion equation, T upon G is equal to G theta over L. So transfer this theta over here and J on this side. So it is T upon theta, that is torque required to produce unit angular deflection. So this left hand side is nothing but torsional stiffness, that is Kt, that is J into G divided by L. Substitute the value of J, then value of G is given in the example, L is also given in the example. So value of torsional stiffness comes out to be 1.079 into 10 raised to 6 Newton meter per radian. Now zeta is damping coefficient divided by critical damping coefficient. Value of critical damping coefficient is 2 square root of Kt multiplied by I in case of torsional vibration. So just cross multiply by these terms. So 2 zeta square root of Kt I, that will be the value of Ct. So Ct will be equal to, just cross multiply by these terms. Substitute the value 2 as it is. Zeta is 0.0644 multiplied by square root of 1.079 into 10 raised to 6, and I is 0.06. So value of damping coefficient comes out to be 32.77 Newton meter second per radian. Now value of natural frequency is square root of kt upon I in case of torsional system. Instead of k upon m, it will be kt upon I. So substitute the values. So kt is this particular value, I is 0.06. So omega n will be equal to 4240.676. Damped natural frequency is omega n square root of 1 minus zeta square. Substitute the corresponding values. So that we will get omega t is equal to 4231.87 radian per second. Now omega t is also equal to 2 pi ft, where frequency is 1 upon time period. So cross multiply by time period over here and transfer this omega t on this side. So that we will get the value of TD, that is substitute the values. So 2 pi as it is, omega t is 4231.87. So value of time period is 1.484 into 10 raised to minus second.